Hello boys and girls, and welcome to lesson 5 from chapter 1. We're going to be looking at graphing. Today we're going to graph, and we're going to graph proportional relationships. Remember that proportional relationships are numbers that increase at the same rate. Okay, they may increase by 4s and they'll always continue to increase by 4, or they may increase by 10 and they continue to increase by 10. Okay, now what I'd like to do here is first let's read and let's get familiar with some of the vocabulary that we have here on the side, okay? A lot of this is a review from grade 6. You've seen this in grade 6, and I know for a fact because I'm teaching grade 6 as well. So when we look at the graph over here, okay, these areas are called quadrants, okay? So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. The whole thing is called a coordinate plane. Okay, the whole graph is coordinate plane because it's the area where we put our coordinates. Okay, so we have the quadrants: quadrant 1, 2, 3, and 4, and then the line, the vertical line, is called the y-axis. Y-axis, and the horizontal line is called the x-axis. Okay, don't forget the x-axis, y-axis. We always go on the x-axis first, and then the y. We go vertical, and then we go horizontal and then vertical. I said that wrong at first. Okay, we need to label. So let's see what we have here. These are actually our coordinates. This is called our order pair. So right there you want to write order pair. This is the order pair that we want to put together. And the first number, okay, is always the x coordinate. Okay, the first one. So we would go 1 over. We always count 1 over first, and then we go up to with the y. We go vertical on the y-axis. So over 1, up 2. You can see that, okay? So this is our x coordinate, and over here is our y coordinate. Number 2 is our y coordinate. Okay, and that's the order pair. So make sure you go ahead and write those things down. Okay, I'm going to turn the camera off and let's do an actual example of how we graph coordinates. Now, just to bridge the lessons, these are ratios. Okay, these are ratios that we've been collecting. We've been working on ratios. And these are actual ratios right here. Okay, so if it's 1 and 2 and I were to double both of them, let's say this becomes 2 and this becomes 4, but it would go 1, 2, 3, 4, and it makes a nice straight line. And then if I doubles again, this becomes 3 and this becomes 6, 3, 6. And you can see that a straight line is being built there, is being created, a straight line. Okay, let's look at that now. Let's look at an actual example. Make sure you fill in the actual labels here. Okay, go ahead and copy those down, please. You can pause the video now. Now we're being asked to graph points 2, 3, and -3, -2 above, right here. Connect the 3 points on the coordinate plane. Describe the graph. Okay, so first we have to plot these points on our graph. Okay, so 2, 3. 2, 3. Okay, there it is. 2, you can see 1, 2, and 3. We always do the x first and then the y. Always horizontal and then vertical. Horizontal and then vertical. Okay, so we go over and up. There's 2, 3. Now we have to do -3, -2. -3 horizontal first. 1, 2, 3. And then -2, 1, 2. Okay, and there you have it. Now, describe the graph. We must describe the graph. Well, if I were to make a line, could I make a straight line? Of course I could. There's no point down here where it's going and turning. It's perfectly a straight line, as you can see right there. Okay, so when we're being told to describe it, we just simply write the points form a straight line. That means, boys and girls, that it is proportional. If we get a straight line, the increments or the increments or the difference is all proportional. Page 46. James earns $5 an hour babysitting. Determine whether the amount of the money James earns babysitting is proportional to the number of hours he babysits by graphing on the coordinate plane. Explain your reasoning in the work zone. So here we have the coordinate plane, okay? And on this side we have the work zone where we're going to explain our answer. So let's graph it first, okay? Let's figure out what our coordinates would be. So let's say James works for 1 hour and he earns $5, right? He works for 2 hours and he earns $10. He works for 3 hours and he earns $15. Am I right? Okay, so this ratio, or these ratios at this rate, they're turning into coordinate planes. Here I have my x and my y, my x and my y, my x and my y. And I was able to know this was my x because I'm saying 1 hour, 1 hour's time is on the x. $5 is on the y. Amount in dollars is on the y. You see that? So now let's graph it. 1 and 5. 1 and 5. 5 is going to be between the 4 and the 6. 2 and 10. 2 and 10. And let's do 3 and 15. 3 and 15 right in between there. Let's graph that. Okay, there we have it. Now we must look at it. Does it make a straight line? Will it give us a straight line? Well, it does actually. So we can say that this is proportional. Okay, explain your reasoning in the work zone. We're going to explain it right here. Okay, you can see there's our straight line. Here's my answer. The amount of money James earns is proportional to the number of hours he babysits. The graph is a straight line, so it is proportional, boys and girls. If it's 1 hour, it's $5. If it's 2 hours, it's $10. It just doubles. If it's continued to doubles, okay, it doubles here. It didn't double here. It's just continuing, but to increase by 5. It's always going to be 1/5, 1/5, 1/5. Okay? Please put a star right there as your key answer. Okay, let's continue to work with graphs and see if they're actually proportional or not. Okay, as you see right here. Let me zoom in and let's take a look at this one. This is page 46, no, 47, I believe. Yes, it is page 47, question B. Now, the table shows the number of calories an athlete burned per minute of exercise. Determine whether the number of calories burned is proportional to the number of minutes by graphing on the coordinate plane. Explain your reasoning in the work zone. Okay, so is this proportional? We're going to graph it. If we do not get a straight line, it is not proportional. Let's graph it. So first let's build our coordinates. So we have number, calories burned. That should be the title right there, by the way. Calories burned. Number of minutes. Okay, so we have 0, 0, 1, 4, 2, 8, 3. I think some of you guys can already see that there's really no pattern. There's a bit of a pattern here, but then we kind of lose it here. You see what I mean? If we have 1 and we have 4, then we have 2 and we have 4. So it doubles. Here it doubled and here it doubled, right? It could double again, or it could just simply go, if it's going up by 4s, it should be 3 and 12, right? If it's going up by 4, it should be 12. It's going to go up by 4. So right away you can see it's not proportional. But let's put our coordinates in line. Okay, as you can see, I've arranged my coordinates. Okay, as my x and my y. The reason this is my x is because x is at the bottom. Time is usually at the bottom, boys and girls. Whenever we're graphing, time is always the x-axis. It shows changes over time when we move from left to right. Okay, and when vertical is usually an amount of money, an amount of calories. It's the amount that it's increasing or decreasing. So you can see here that we have 0, 0. So that'll be our first point right there. And then we have 1, number of minutes, 1, right there, 4. So we go 1 and we go up to 4. So there should be our second point. 2 and 8, 2 and 8, and 3 and 13, 3 and 13, right in the half there. And there are my points. Now if I really wanted to just draw a line through, I could start by drawing a line there like that, so like this going up, but then as you see I kind of have to curve right there to go up. It should go right through. It should go like this, and it should go through that 12 if I wanted to keep it straight. So you can see my line right there is actually not going through the point. It curves off. The next point curves off, so therefore it is not proportional. Okay, so now let's move over here and explain our answer. It is not proportional. The line is not a straight line. The graph is not a straight line. Okay? You see it right there? It's not straight. Okay, this is a key answer. There we go. With the tongue. Okay, finally, let's look at page 48, the guided practice. As you can see right there at the top, the guided practice. Okay, number 1. There we go. The cost of 3D movie tickets is $12 for one ticket. There's our ratio, 1 to 12, right? One ticket is $12. $24 for 2 tickets. Well, you double this, you double this. $3, 3 tickets for $36. So we continue, right? Well, now it's tripled, and it's tripled 3 times 12. It's 36. Determine whether the cost is proportional to the number of tickets by graphing on the coordinate plane. Now, boys and girls, I know that many of you know just by looking at this that this is proportional. So you could just go yes right away because you're able to see that 1 is 12, so 2 must be 24 because you're doubling the 12, and then 3 must be 36 because you're tripling the 12. You're tripling it, right? So yeah, this is a proportional ratio. Now, the idea is that we have to graph it. We just have to show that we know how to graph. So let's go ahead and graph these. Make sure you organize your coordinates, okay, as you have right there, your ordered pair. I put all the X's on one side and all the Y's on the other side. And these are my X's, again, because I'm counting the number of tickets. 1 ticket is 12. 2 tickets is 24. And 3 tickets is 36. Go ahead and graph those. Okay, I graphed mine right there. Sorry, my 12 is a little bit off. It's a little higher than it should be, but it's hard to draw on the iPad. But there we go. There's a straight line. Okay, so let's write it out. Let's write it out right there. Okay, so simply, yes, the cost is proportional. The graph has a straight line. Go ahead and write that down. Okay, don't just write the yes, please. Don't just write the yes. Write all the words that you said. Yes, the cost is proportional. There is a straight line on the graph. Please write that down. Number 2. The number of books 2 stores sell after 1, 2, and 3 days is shown. Okay, 1, 2, and 3 days, times in days. Which book sale represents a proportional relationship between time and books? Okay, so they sold, by days, they sold the exact same amount of books. Day 1, for example, the Book Palace, day 1, they sold 3 books. Day 2, they sold 6 books. Day 3, they sold 9 books. So 3 books one day, 3 books the second day, and 3 more books the third day. That looks proportional to me. What about the discount bookstore? The one day, they sold 1 book. The second day, they sold 3 books, 3 more books, so a total of 4. And then the third day, they only sold another 1 book. That is not proportional, as you can see. The Book Palace has a proportional relationship. The graph is a straight line through the origin. What we mean by through the origin means this is the origin, where we have 0, 0 is the origin. So if it's proportional, it's going to go straight through the origin and continue on to the negative side if we need it to. So that's what it means, through the origin. Okay, this is also a key answer. I'm going to draw a flower for this one. Some of you might not like flowers, but I really like flowers. So there we go. I look forward to your flower. And finally, how does graphing relationships help you determine whether the relationship is proportional or not? Well, if you haven't figured it out yet, boys and girls, the reason we graph it is to see if it's a straight line or not. The graph of a proportional relationship will be a straight line and pass through the origin. Alright, this is it. See you in class.